तो हेलो गाइस। आज मैं आप लोगों को अपनी वेबसाइट जो कि मैंने अपने समर्स में अ, बनाई थी एज अ वेब डेवलपमेंट एंड उसके बारे में आपको बताना चाहूँगा। सो अबाउट द कंटेंट ऑफ द वेबसाइट, in this website I have included some templates of like disjoint, set union, segment tree, lowest common ancestor. For example, you can put the templates and if you want to know what is DSU, so first of all, I assume that you know a little bit about DSU, and because I have just given you the link for the course which can be used directly. So, for example, this is the code for the DSU, and here I have also explained in the comments how to use the DSU data structure. For example, suppose we have n nodes here, n is equal to 10, so we have 10 nodes. So we just have to declare a DSU. You can name it anything you want of size n here. So here the find function finds the parents of the node. So what is the parent of one will be DSU dot find one. इनिशियली जो वन का पेरेंट होगा वो वन ही होगा, क्योंकि वही डीएसयू का कॉन्सेप्ट है। जब हम लोग कनेक्टेड कंपोनेंट्स को कनेक्ट करते हैं उसके बाद चेंज होता है पेरेंट। तो सपोज इफ यू यूनाइट पर node 1 with node 2, then after that if you will print the size of the node 1, we will give it will give uh, 2, because now 1 has connected to 2. So these are the things. And so let's do an example of BSU on my website. Here I have given problems in the increasing order of difficulty. I have included many topics like advanced topics, some intermediate topics, and well, some starters. You are starting in the beginner section. Uh, you will have some problems, very standard like stack, linked list, and all these problems. And brains after some problems which require some sort thinking, and yes, you can definitely do it. And I have also included this section brute force type problem where just a brute force solution will work. Let's do some DSU beginning. See the problem. So the problem states that implement DSU. So we have to perform two types of queries, union u comma v. So we have to unite two sets u and v and get u comma v. So check that two elements u and v belong to the same set. So this can be done using DSU. So let's copy paste for DSU from here. And let's do it here. First line of input contains two integers n and m, the number of elements and the number of queries. Okay. For a query union, the line looks like union u comma v. Sorry, uv. For a query get, the line looks like get. Okay. Let's do it. N and M. Then we have M number of queries. In each query, we will get a string first. Then we will get two integers, u, comma, v, take and two. Let me define the DSU. So here, let me explain something about it. Uh, when you call the function DSU, the constructor will set this vector element with vector of integer of size n and uh, with values -1. The value -1 indicates that it isn't the node isn't connected to any other set. So it has only one component. I mean one node. Find function here. By find function will find the parent of x. So if element of x is negative, that means that it is the parent of it. Else we should return the element of x equal to find the parent of element of x. And here the size function gives me the size of the uh, component in which the node x belongs to. And the unite function unites two nodes, two sets where A and B are their nodes. Let's declare the DSU. Size. Here we are given in 1 to n range, so we have to decrease them by 1. Uh, we also have to let them to 0. Yeah, then the query of type first. If our string is a union string and we have to unite u comma v, then we just simply unite them using the unite function. U dot unite. It asks us we have to check if the two elements belong to the same set or not, then we should just check the parents of u and v, and if they are same, then they belong to the same set, else different set. So, parent of u or I parent of u. Simply parent of v dot find v. Pu parent of u is equal to parent of v, then they belong to the same set. What we have to print, we have to print yes if they belong to the same set. We have print you are done. Let's check it. Okay, the answer is correct. So let's submit. So you can see how you can implement copy paste PSU and use it in your questions. Let's do some good question. This question. Journey to the moon for the hacker rank. So the problem states like this. The member states of the UN are planning to send two people to the moon. They want them to be from different countries. Okay, you will be given a list of pairs of astronaut IDs. Each pair is made of astronauts from the same country. So if 1, 2 appears in a pair, then this means that 1 and 2 belongs to the same country. Determine how many pairs of astronauts from different countries they can choose. So let's consider this example. If there are four astronauts which are numbered from 0, 1 to 3, and we are given two pairs. In the first pair, uh, the astronauts 1 and 2 belongs to the same country, and in the second pair, it is given that astronauts 2 and 3 belongs to the same country. So let me make it more clear. So let's say let's say there is a country A and there is a country B. So initially it is given that astronaut number 1 and astronaut number 2 belongs to the same country. So let's say the astronaut 1 belongs to the country A. So if 2 also belongs to the same country, then it should be uh, from country A. And in the second pair, it is given the astronaut 3 belongs to the same country. As astronaut 2 here is belongs to the country A, so 3 should also belong to the country A. So here we can sense that we have to use DSU to know uh, how many people belongs to the different countries. So the problem now converges to finding out how many different connected components there are. Suppose there are some three connected components: A, B, and C. Now, let's say country A has some number of astronauts x1, and country B have some x2 number of astronauts, C have some x3 number of astronauts. So, how can we choose two astronauts from different countries? Now the question is mathematical. So it can be easily seen that if we allow us to choose one astronaut from the country A and one astronaut from the country B, then we can choose from country A in x1 different astronauts, and from country B x2 types of astronauts. Also, we can also choose an astronaut from the country C. So these will be the number of cases where one astronaut is from country A. Now, if we make the same thing again for the country B, we have to plus x2. Now x3 has been included in every zero. So now we can sense that if there are some, let's say, m number of countries, and they have some x1, xm number of astronauts, and the best way to solve the answer can be psi multiplied by all the number of astronauts ahead of them. Psi plus 1 plus psi 2, 2. This is for the case when one astronaut is fixed from the country I. So we will just have to sum this up for every I. So we can do this using some prefix summary. This is nothing but uh, just a suffix sum. So we have to use prefix summary with ESU. So let's implement that. Both the are given. Let me check. The first line contains 2 integers and 20 the number of the okay. We have to declare a TSU of size here as well. Now I have to take the input. Let's take it. Remember that we are using zero based indexing here. So we are decreasing. Now should reunite them as A comma B belongs to the should belong to the same country. So we have united them now. Problem. Now I have to find these x1, x2, xm's. So how can I find them? So one thing to note down here is that let's we can create a vector of where we will throw the astronauts and we will check for each astronaut which belongs to which country. So uh, if parent of IF astronaut is himself, then we have found a new component, and we also want to know the size. So we should suspect the size of this component. Um, This is our some xi or xj. Here may not be n different components. I have to make a prefix array. I know prefix. That's fine. M other. Here my prefix array will be one based index. It, it looks easy for me, so I do it. Now I just have to calculate my answer. For that, let's first create the prefix array. Pick of I plus I one. Let's say our answer is 0. So for we are at higher position, then we need a sum from I plus 1 to the last index. So our answer would add up I so wait, from where so we can take the there, take uh, okay. So yeah, I can see that zero based indexing is so I didn't I shouldn't have decreased them by let's see what's currently yes, let's submit that of the test cases. Yes. So this is the way how one can use BSU. There can be many other ways as well. I give you a task to understand this. What does this? How does this code uh, find out the different components and their sizes? Can you guess it? Okay.